ஏரியாவுக்கும் will be having ஒரு exhaust systems. அந்த ஒரு exhaust system என்னன்னா ஒரு சிஸ்டம் ஓடிட்டு இருக்குன்னா அதுக்கு ஸ்டாண்ட் பை 100% ஸ்டாண்ட் பை. ஒரு எக்யூப்மெண்ட் இருக்கிற இடத்துல we'll have 2 equipments அது ஸ்டாண்ட் பை. ஏன்னா இந்த எக்யூப்மெண்ட் இந்த ஹாட் செல் அந்த எக்ஸாஸ்ட் ஒரு எக்ஸாஸ்ட் ஓடலைன்னா வாட் இஸ் த லெவல்னா people cannot be allowed to work in a radioactive laboratory environment. ஒரு எக்யூப்மெண்ட்ல ஓடிட்டு இருக்கு இந்த எக்ஸாஸ்ட் ஓடல ஏர் கண்டிஷனிங் வென்டிலேஷன்ல ஒரு எக்ஸாஸ்ட் சிஸ்டம் ஓடல அப்படின்னா எமர்ஜென்சி டிக்ளேர் பண்ணிட்டு உள்ள இருக்கவங்க எல்லாருமே வெளியே வந்துடும். ஏன்னா இது ஒரு சேஃப்டி ப்ரிகாஷன்ஸ். சப்போஸ் அந்த மாதிரி ஆஃப் ஆர் நேரத்தில் ரேடியேஷன் வெளியே வந்துச்சுன்னா சேஃப்டி அந்த லெவலுக்கு ஆஃப் சேஃப்டி இஸ் பீங் ஃபாலோட். ஸோ ஒரு எக்யூப்மெண்ட் பார்த்தீங்கன்னா இட் இஸ் அ ரொட்டேட்டிங் எக்யூப்மெண்ட். எனி ரொட்டேட்டிங் எக்யூப்மெண்ட்ஸ் வில் ஹேவ் இட்ஸ் யூசுவல் வார்ன் அண்ட் வேர் அவுட். இன்னும் கொஞ்ச நாள் ஆச்சுன்னா பேரிங் ஃபயர் ஆகும், வேற எந்த எக்யூப்மெண்ட் ஃபெயிலியர் ஆகும். ஸோ ஒரு எக்யூப்மெண்ட்டுக்கு ஒரு ரெஸ்ட் தேவை. அதே மாதிரி ஒரு எக்யூப்மெண்ட் cannot run for 365 days 24/7 போட முடியாது. ஸோ we'll have 2 systems, ஒரு ரன்னிங் ஒரு ஸ்டாண்ட் பை. Generally what is the system followed is we'll operate a equipment for 15 days. ஒரு மந்த்ல வந்து first 15 days one equipment will be under operation. அந்த 15 daysல அந்த பக்கத்துல இருக்க system will be stand by இருக்கும். Any maintenance anything is there, it will be done during this period and it will be ready to operate at any time. The ஓடிட்டு equipment trip ஆயிடுச்சுன்னா ஸ்டாண்ட் பை உடனே ஆட்டோமேட்டிக்கா அதே வந்துடும். அண்ட் அந்த 15 days இன்கேஸ் அது எதுவும் மெயின்டெனன்ஸ் எதுவும் ப்ராப்ளம் வரலன்னா 15 days ஒரு எக்யூப்மெண்ட் ஓடும். 15th day முடிஞ்சோடனே 16th day அன்னைக்கு we will manually stop the running equipment and start the standby equipment. அப்புறம் இந்த 15 days வந்து இந்த எக்யூப்மெண்ட் ஸ்டாண்ட் பைல இருக்கிற எக்யூப்மெண்ட்ஸ்க்கு ஆல் மெயின்டெனன்ஸ் அண்ட் திங்ஸ் will be carried out. That is how continuous operation of ventilation system is ensured. Next level is like various instrumentation and surveillance. Any system நீங்க போட்டீங்க அப்படின்னா it should be properly monitored. So then in case எங்களோட radioactive facilities எல்லாம் பார்த்தீங்கன்னா it will be under Atomic Energy Regulatory Board. They are the person who give permission for operating radioactive facilities. So in case என்ன radiation release வந்து இது அப்படியே என்ன ஆகும் எல்லாமே வந்து அவங்க கண்ட்ரோல்ல இருக்கும். So anything is there we have to monitor the system, record the systems and give the reports to the competent authorities whenever they come for inspection. Generally 1 year once they come for inspection of these facilities and we'll have internal team auditing teams. They'll every 2 months 3 months they'll review all the systems and give their comments. So on the surveillance thing is like you require proper instrumentation and surveillance. So in the blowerல வந்து எவ்வளவு flow measure பண்ண போயிட்டு இருக்கு அப்படின்றது it is mandatory to measure. So this is one of the flow measurement device. How do you measure flow அப்படின்னு பாத்தீங்கன்னா there are various methods. இதுல ஒரு மெத்தட் வந்து velocity தெரிஞ்சதுன்னா you can measure you can calculate the flow. How do you calculate? Flow is nothing but area into velocity. So in the ductல வந்து ஒரு this is called as hot wire probe, hot wire anemometer. Anemometer measures the pressure flow in meters per second. So in the reading la it gives 1.19 or 1.2 meter per second under the velocity is giving. Next, once velocity is known, we'll have the dia of this duct is around 500 mm of dia. Abinna 5/4 d square. We'll be able to find the area. When you measure the area and the velocity, you'll be able to get what is the flow of the air passing through this duct. This is all mandatory in ventilation system measurement. And we'll have pressure switch. ஒரு சிஸ்டம் ஓடிட்டு இருக்கும்போது ஒரு pressure will be maintained. If ஒரு pressure வந்து என்னாச்சுன்னா இப்போ எல்லாம் ஆபரேட்டர்ஸ் they will be at various locations. ஒரு blower ஓடிட்டு இருக்கு ட்ரிப் ஆயிடுச்சு அப்படின்னா the pressure will come down and there will be a sense in the pressure switch and this will give an alarm in the control room so that உடனே operator will take necessary action என்ன பண்ணணும்ன்றது. And we will be having differential pressure measurements. The filters are nothing but வீட்ல காஃபி தூள் டீ எல்லாம் போடும்போது we use a filter பாத்தீங்களா. It is similar to that. The efficiency varies. So what happens, நீங்க இனிஷியலா ஒரு எக்ஸாம்பிள் என்ன சொல்றேன்னா ஒரு காஃபி டீ தூள் டீ போட்டுருக்கீங்கன்னா so initially you put that tea decoction and things, then you filter it. When you filter, when you pour this water with this tea leaves and things, what happens, initially it flows fast in the filter. Once it is getting choked, what happens, it slowly passes. So என்னன்னா அப்போ வந்து உங்களோட flow rate குறையுதுங்களா. But we have to maintain the required flow in a ventilation system. நம்மளோட required என்னென்ன ஏர் சேஞ்சஸ்ல மெயின்டைன் பண்ணணும். ஸோ அதுக்கு வந்து ப்ராப்பர் அரேஞ்ச்மெண்ட்ஸ் ஆர் தேர் இன் ventilation system. Dampers will be opened, closed, and the filters வந்து if it is initially I said in the previous slides பார்த்தீங்கன்னா it will be around 25 mm of water column சொல்லிருந்தேன். So during course of choke, dust இதை choke ஆகும்போது when it reaches around 75 mm, we have to replace. Our systems are designed for 75 mm of pressure column, mm of water column. So on the 75 mm வந்துச்சுன்னா we will take action to replace the fresh filters. So other measure பண்றதுக்குலாம் we will be having differential pressure transmitters. So ஒரு mechanical ஒண்ணுதான் இல்ல. So in case nowadays ventilation, air conditioning ventilation is not only for mechanical engineers. There are a lot of opportunities in field of electrical instrumentation, computer, because in IoT has come. Internet of Things has come in all the things. இப்போ இன்னைக்கு வந்து நீங்க window split air conditioning everything, when you are coming from your office, at least for half an hour முன்னாடியே you can program it and tell your split AC or to be on, so that நீங்க வீட்ல வந்தோம்னா full cooling இருக்கும். அது மாதிரி there are a lot of opportunities for air conditioning and ventilation engineers. It is not only in the for mechanical engineers. Now it is this air conditioning and ventilation field is taking the multidisciplinary. It requires electrical engineers because we have motors, pumps, various things. இதெல்லாம் operate பண்றதுக்கு, maintenance பண்றதுக்கு, design பண்றதுக்கு we require a lot of other engineers also. Electrical, instrumentation, computer science, because all programming, everything it requires other level of engineering. So these are how the data are being recorded. So next is central surveillance. Now comes the part of an instrumentation or electronics and computer science engineer, where people in the data there are programming being done to record all the values. So the ventilation surveillance systems, these are called as ventilation surveillance system. Data of various parameters are recorded in the computer and monitored using central surveillance systems and can be accessed through local area network. So these are all we have introduced in our system also. Ventilation systems are components are have fail-safe features with provision for alarm indication. இதெல்லாம் வந்து இப்போ ஒரு சிஸ்டம் ஓடிட்டு இருக்குன்னா அதோட என்னென்ன parameters, pressure என்ன, temperature என்ன, எவ்வளவு flow, everything is monitored and through authorized person. I am the engineer in charge for ventilation system. Through my PC, I can see what are the systems are running, what is the flow parameters, when I have to take maintenance, when it has stopped for maintenance, before the pressure, everything is possible for me to sit from a PC and check all the parameters. So this is the central surveillance system, which is now very much important in nuclear establishment. So almost I'm coming to the end of my presentation. Is okay now, sir? Just 5 minutes more. So next level, any radioactive facility, if there is going to be a ventilation failure, people will not be allowed to go in. So emergency work, we have got a special feature called as breathing air or mask air system is very much important. So whatever radioactive facilities, these types of system will be compressed air, breathing air with low pressure regulator will be available. And the room வெளியே இந்த மாதிரி ஒரு மாஸ்க் ஷீல்ட் எல்லாமே இருக்கும். So என்ன பண்ணனா, this there will be a quick release coupling. The hose எடுத்து we can just connect it and இதெல்லாம் வந்து filters எல்லாமே செட்டப் இருக்கும். They can put into the face because contamination ஆனதுக்கு அப்புறம் they cannot breathe the normal air inside this. So அந்த மாதிரி கேசஸ்க்கும் வந்து this breathing air plays an important role, and they can use these types of apparatus to go inside for short duration to any ஒரு எக்ஸ்பெரிமெண்ட் ஸ்டாப் பண்ணணும், வால்வ் ஆஃப் பண்ணணும், ஏதோ ஒரு மேஜர் எக்யூப்மெண்ட் ஓடிட்டு இருக்கு அதை ஆஃப் பண்ணணும், இந்த மாதிரி ஏதாவது ஒரு மேஜர் எக்யூப்மெண்ட் பண்றதுக்கு these types of facilities very much available in any radioactive facilities. And this air, because the air வந்து is going to be breathed by person in case of emergency. So the breathing air quality will be regularly checked, it will be regularly flushed so that emergency use பண்ணும்போது it will be available or in good condition. So 100% standby systems are provided for all supply and exhaust, and they are electrically and mechanically ready to operate at anytime. No safety features. And the outlet dampers of critical system. Now glow box, hot cell na sonna pathingala, adukku ellame anti backflow dampers nu irukum, so that matha system open agumbodhu idu valiya backflow aagi system edum pressure pannakodadu. So adukana system kaga we will be having anti backflow dampers. These are dampers with pneumatic actuators which will be placed in the ventilation ducts. So next, normal I said about radioactive ventilation. For normal ventilation or radioactive ventilation, no difference. So radioactive ventilation, it is in nuclear establishment. So normal ventilation, college or conference room or IT park or building, air conditioning, or radioactive air conditioning, what is the difference? Once through, I said, recirculated. We have multi-zone ventilation system. Ventilation zone, white, green, amber, red, various zones are there. It is normal ventilation. Negative pressure will be maintained, positive pressure. Negative pressure, safety of general public is ensured. இங்கே ஃப்ளோ பேட்டர்ன் இஸ் மெயின்டைன். லெஸ் ஆக்டிவ் வந்து மோர் ஆக்டிவ் வழியாக தான் காற்று எப்பவுமே போகும். ஸோ இங்கே அந்த மாதிரி எதுவுமே கிடையாது. ஸோ இந்த ஹீட் லோட் கால்குலேஷன் இப்போ வந்து அது இங்கே ரேடியோ ஆக்டிவிட்டி பேஸ்டு ஹீட் லோட் கால்குலேஷன் இருக்கும். இங்கே வந்து ஹீட் லோட் கால்குலேஷன் தான் பேசிக்கலி. இங்கே ரேடியோ ஆக்டிவிட்டி பேஸ்டு என்ன டைப் ஆஃப் ரேடியேஷன் மெட்டீரியல் யூஸ் பண்ணுறீங்க அதை பேஸ் பண்ணி தான் இந்த டிசைன் கால்குலேஷன் இருக்கும். இங்கே வந்து ஹீட் லோட், இப்போ நீங்கள் ஒரு பில்டிங் பண்ணுறீங்கன்னா அந்த பில்டிங்ல எத்தனை பேர் உட்கார போகிறாங்க, அந்த பில்டிங்ல வர்றது எலக்ட்ரிக் லைட் சோர்ஸ் இருக்கு, எத்தனை கம்ப்யூட்டர்ஸ் இருக்கு, அந்த மாதிரி பேஸ் பண்ணி தான் இங்கே ஜென்ரல் ஹீட் லோட் கால்குலேஷன்ஸ் இருக்கும். இங்கே ஏர் சேஞ்சஸ் பர் ஹவர் வில் பி வெரி ஹை. நான் என்ன சொல்லியிருக்கேன் 25 to 30 ஏர் சேஞ்சஸ் பர் ஹவர் வரைக்கும் போகணும். இங்கெல்லாம் ஜென்ரலாக 2 to 3 ஏர் சேஞ்சஸ் பர் ஹவர் வில் பி ஜென்ரலி அடாப்டட். These are the basic difference between the radioactive ventilation and normal ventilation. What are the facilities in a nuclear ventilation facility? என்னென்ன equipments ஜென்ரலா இருக்கும் அப்படின்றது உங்களுக்கு கிளிம்ஸ் கொடுக்கறதுக்காக பார்த்தீங்கன்னா generally we'll be having air handling units, fan coil units, supply systems, exhaust systems, chillers for producing chilled water, cooling towers for condenser cooling, compressed air system for emergency breathing air applications, chilled water booster pumps, condenser pumps, அப்புறம் various instrumentation and controls. நான் சொன்ன பதிலாம். These are the various facilities which are very much required in the nuclear facilities. Glimpse of photos பார்த்தீங்கன்னா this is a one air handling unit. This is a cooling tower. These are one pumping systems. So இந்த pumping systemல since it's handled low temperature around 8 to 10 degrees இருக்கனால heat loss இருக்கக்கூடாது. These are insulations. I said about the insulation la and the insulation materials. These are blowers, various capacity blowers which are available. For our small capacity we have 900 cmh and around 50,000 cmh capacity varaikkum blowers are available. We have compressors, we have chillers for chilled water producers. These are various equipments which you generally see in a so generally multi-zone ventilation ducts for nuclear facility. So generally enna sonna pathina we will have various systems. So எங்களோட சிஸ்டம் பார்த்தீங்கன்னா ஒரு எக்ஸாம்பிள் டிபிக்கலாக பார்த்தீங்கன்னா this is one system, low level system, high level system, glow box system, hot cell system, high bay area and இன்னொரு level. So various systems இருக்கு, various blower systems, இதெல்லாம் ducts. These are being connected to a common RCC stack. ஜெனரலாக பார்த்தீங்கன்னா இது வந்து 1.2 மீட்டர் பை எங்களோட இது பார்த்தீங்கன்னா 1.2 மீட்டர் பை 1.2 மீட்டர் இன்டூ அரௌண்ட் ஒரு 40-50 meters duct இருக்குது RCC duct. இது போயிட்டு this will be let out to a to a common stack. Generally stack என்றது என்ன சொல்றோம் புகை போக்கின்னு சொல்லுவாங்க. It will be designed based on the type of radioactivity material, பக்கத்துல எவ்வளவு டாலஸ்ட் பில்டிங் இருக்கோ அதை பேஸ் பண்ணி தான் வந்து இந்த ஸ்டாக் ஹைட் will be designed. இப்போ ஜெனரலா இப்போ எங்களோட பில்டிங்ல RCA அங்க பாத்தீங்கன்னா we have got a 775 meter height stack through which the radiation and the material the புகையெல்லாம் வந்து வெளியே அனுப்புறதுக்கு வந்து it will be let out through this stack. ஜெனரலா this is the basically என்னன்னா இவ்வளோ ஏர் எல்லாமே after filtration it from the various facilities will be filtered through HEPA filters and it will be sent through stack. Generally in the radioactive facilities 1 to 2 level of safety will be ensured. என்னன்னா இப்போ அவங்க என்ன கேட்பாங்கன்னா நீங்க வந்து இந்த ஃபில்டர் பாயிண்ட் போதும்னு சொல்றீங்க, இப்போ இங்க எதுவுமே ரேடியேஷன் எதுவும் லீக் ஆகலன்றது எப்படி நீங்க என்ஷூர் பண்றீங்க அப்படின்ட்டு level any system is prone to damage. So அதுக்கு என்ன பண்ணுவோம்னா we'll have a secondary system. So இந்த ஏர் வெளியே போகுது பாத்தீங்களா, வெளியே போறதுக்கு முன்னாடி அங்க இருந்து ஒரு டேப்பிங் பாயிண்ட் எடுத்து we'll have a stack monitoring system சொல்லுவாங்க. அதுல இருந்து ஒரு பர்டிகுலர் ஏர் பார்ட் எடுத்து it will be counted for activity levels. So ஏன்னா ரேடியேஷன் ரிலீஸ் இருந்தா அதுல இருந்து கண்டுபிடிச்சோம். So these are 2 to 3 levels of safety which is being followed in a radioactive system. And in the radiation maintenance systems la வந்து refurbishment of AC and ventilation system in a radioactive environment needs special planning, approval from various committees, special work permits, health physics clearance, proper work execution, proper testing and commissioning, minimum downtime, and we have to follow all the safety and regulatory requirements. So yes, இப்போ நார்மலா ஒரு எக்யூப்மெண்ட் ரிப்பேர் ஆயிடுச்சு, ஒரு பம்ப் ரிப்பேர் ஆயிடுச்சு, நார்மலா ஒரு ஏரியானா அதை ரிப்பேர் பண்றது இதெல்லாம் வந்து ரொம்ப ஈஸி. பட் இந்த மாதிரி ரேடியோஆக்டிவ் சிஸ்டம்ல உள்ள எக்யூப்மெண்ட்ஸ் வந்து மெயின்டெனன்ஸ் பண்ணணும்னா வந்து இட் ரிக்வயர்ஸ் ப்ராப்பர் பிளானிங். இந்த மாதிரி ஏதோ பண்ணணும்னா இட் ரிக்வயர் ஒழுங்கு ஃபர்ஸ்டே பிளான் பண்ணி அது வந்து வேரியஸ் லெவல் ஆஃப் கமிட்டிஸ்ல போய் அப்ரூவ் பண்ணணும். அவங்க கிட்ட ப்ரொசீஜர் சொல்லி how we are going to do everything should be explained to the committee. What are the implications if there is going to be any mismatch அந்த மாதிரி இருந்தா, and we have to get special work permits. ஏன்னா அந்த இடத்துல வந்து some radiation release இருக்கலாம், அதுக்கு அவங்க வந்து they will take some samples, activity level எவ்வளவு இருக்குன்றது மெஷர் பண்ணுவாங்க. அதுதான் that is called a health physics clearance. That is they are like doctor. Any radioactive facility நம்ம எப்படி ஒரு நார்மல் இடத்துல ஒரு டாக்டர் தேவையோ அதே மாதிரி ஒரு ரேடியோஆக்டிவ் ஃபெசிலிட்டிஸ்ல ஒரு டாக்டர் மாதிரி தான் ஒரு பர்சன் ஹெல்த் பிசிஷியன் சொல்லுவாங்க. He is the person who gives clearance for carrying out any radioactive material. he has all equipments which measures the radioactive. உள்ள போகாமே வந்து ஒரு சில வெளியே இருந்தே சில எக்யூப்மெண்ட்ஸ் வச்சிருப்பாரு. அங்க எவ்வளோ ரேடியோஆக்டிவிட்டி லெவல்ஸ் இருக்கு, ஏர் சாம்பிள் எடுத்து பார்த்துட்டு, ஸோ இதெல்லாம் பேஸ் பண்ணி ஹி சஜஸ்ட் உள்ள போறதுக்கு எக்யூப்மெண்ட்ஸ் உள்ள போய் வேலை செய்யறதுக்கு என்னென்னலாம் சேஃப்டி ப்ரிகாஷன்ஸ் ஹஸ் டு ஃபாலோ எல்லாம் ஹி சொல்றது பிரகாரம் தான் வந்து ஒர்க் வில் பி கேரிட் அவுட் அண்ட் ஒர்க் வில் பி எக்ஸிக்யூட்டட் இன் ப்ராப்பர்லி. யூ ஷுட் நாட் கோ டு ரீஒர்க் ஏன்னா இதில் ரேடியோஆக்டிவ் இருக்கு. அண்ட் ப்ராப்பரா ஒர்க் முடிச்சு இட் ஷுட் பி டெஸ்டட் அண்ட் கமிஷன்டு. And whatever work we do, it should be done with minimum downtime. So these are the major things. And if it is going to be an running plant, if I switch off my exhaust system, people cannot go inside. So whatever work I have to do, it should be planned on holidays or after office hours. Most of the maintenance work will be carried out so that works are not affected. So whatever work we do, it should not affect the lab activities. So emergency preparedness, in case of ventilation failure, plant emergency to be declared and staff members working had to be vacated, had to vacate the lab. So that's what I'm. So ventilation is the heart of the any radioactive facility. And the exhaust blower what happens na exhaust blower we have to declare that the lab emergency procedure. Declare we have all announcement system. We'll announce that there is a ventilation failure. People have to come out of the laboratory. People equipments safe off they'll come out of the laboratory. Ventilation illa radioactive materials release emergency condition. The safety we follow all this. So we'll declare an emergency. People will come out of the laboratory, and once the ventilation system the problem solve people will not be allowed to go in. The lab the health physician he will go into the lab, check active sample measurements, air sample, he takes samples and checks for there is no radioactivity release. He gives clearance for people to go into the laboratories or the workspace. This is how safety is being incorporated in a ventilation system. So I would like to thank you students and the staff members of Agri College of Technology for giving me this opportunity and for your all patient hearing. And I'm sorry that I couldn't start in time because of my small issue in the network. And any questions, I would be happy to clear your doubts. Over, sir.
Thank you so much, sir. The participants, you can ask your questions if you have any.
Any questions? Okay, we'll wait for some time. There are two things. If there are no questions, that I can take in two ways. You have understood everything and there are no doubts. Other thing is you are not understood about anything what I have told. I will take it in the first sense that you have understood everything. Is it okay?
Students, if you have any doubt, you can ask openly. Tamil or English, whatever, no problem. You can ask the questions.
Yes, any language is okay. English, Hindi,
yeah.
Tamil. Or you can put your questions in chat box if you have any.
Sir, I have a question, sir.
Yeah, sure.
Recently, I read in newspapers that scientists from Purdue University has developed an ultra-white paint, which when comes out to market would totally remove all home air conditioning units. Can it be a potential threat to the air conditioning units? Will it be efficient?
Pardon, please put me, it's not clear for me.
So I read it in a newspaper that the Purdue University has developed a ultra-white paint. It is said that it will remove all air conditioning units from home. Is it a potential threat to air conditioning units?
It's not potential. What happens is whether it gives any cooling effect to the rooms or anything?
Yes, sir. Yes, sir. It gives a cooling effect to the house.
See, what happens is it cannot be a threat because now condition, whatever this paints and things, it can gain of around 1 to 2 degree maximum. If you see, until now temperatures are very much going up. So with the present condition, it can just get 1 or 2 degrees maximum. But now the requirements has come that many equipments, laboratories or any commercial equipments, they are asking now temperatures till 22 or 21 degrees also they are asking for various applications. These cannot as such go out with vanishing. So it is on small type of improvements which in case only low application, this can be used, but it cannot replace the whole ventilation, air conditioning ventilation equipments.
Okay, sir. Thank you.
Right.
So there is one more question from a student.
Yes.
He's asking that if we are using more and more ACs in the future, will it lead to more rise in global warming?
Yes, that is the major thing which is being caused for this global warming, the air conditioners. That is what in my presentation you would have seen about eco-friendly refrigerants. So previously, if you see, there were CFCs like R11, R22. Now the stage has come because of various signing up agreements like Giga agreements or thing. Now we are phasing out slowly because now we cannot phase out the refrigerants at it drastically. So if R22, they said by 2040 it has to be phased out. But now what they are telling us, though it is 2040, by 2030, mostly R22 will be phased out. Now we are going into all energy friendly, eco-friendly refrigerants, like I said, R134, 410A. Once these are being used, no, this global warming will slowly come down.
Thank you so much.
Yeah.
Participants, do you have any more questions?
Hello.
Yes.
Good afternoon, sir. Hello.
Good afternoon. Yes.
Sir, very nice presentation. I am also working on the refrigeration and air conditioning field in my Tech. So, sir,
Okay.
I have some questions regarding
Yeah.
the carbon dioxide as a refrigerant in a
Yes.
new technology for heating and ventilation for building and industrial plant.
Yes.
Is there any new technology in the recent development in your research X-ray organizations?
Yes, sir. There is a major development. One carbon dioxide plant itself, one setup is being developed at IIT Madras, where Professor MP Maya is taking care of this whole setup. So there are lots of activities going on with carbon dioxide as a refrigerant because he has given one nice presentation. If required, sometime we will arrange for you also. And there is a plant available in IIT Madras. If you have a chance, you can go there because lot of R&D activities are going on with CO2 as refrigerants. And there are potential things that you will be able to save. ISRE is also taking in a lot of initiative in this action, and Professor MP Maya from IIT Chennai, Madras is doing a lot of activities on this. He'll be able to give you much idea. In case anything is there, you can come in touch with me separately. I'll guide you for you anything which you require.
Any project collaboration with ACT for this?
Actually, yes, sir. You are not coming forward. You have come forward. That is, there are a lot of opportunities. ISRE is coming out with project grants. If you are a ISRE member and willing to do a project work in the field of HVAC, you have to submit a proposal. And to this proposal, ISRE is sanctioning around 50,000 to carry out this proposal. 31st of September was the 15th of this month, September was the last date for sending the proposal. We have not received any proposal from your college. We have received 2 proposals from Amit University, but we are posting all this in your groups, but you have not come forward. If you have to come forward, then we'll be able to help you out in anything. Because for UG, it is giving around 50,000. For PG, it is still more higher, I think 75,000 or 1 lakh. But it will be selected. There is a form available where you have to fill up with all the details of your project, with your references, and your department has to endorse this project, and it will come to us as a history chapter. We will check for it and we will endorse and send it for project approval. So similarly, all project grants will be sent to that committee, They will be scrutinizing it, and the best some 5 to 10 based on the funds and available. They will, if they have allotted around 50 lakhs or something for this project proposals, based on the fund and everything, it will be sanctioned. And what they do is, once the project is sanctioned, they give you an initial one-part payment where you can buy your equipment and other things. Then you have to do some work. Then you have to present your presentation to the committee. Similarly, they will release part by part, and you can complete your project with no cost of your own. ISRE itself is taking care of such projects, grants. You have to take this opportunity. There are still some decathlon and some programs available, which we'll share in your group. You can take it forward and you'll be able to learn much. My thing is, getting a prize or award is secondary. If you get into this type of writing reports and applying for this, you'll get a lot of knowledge and you will try to learn many things. That is my part, which I am telling you have to do.
Okay. Thank you, sir.
Yeah, in this carbon dioxide, if you have any issue, you can get into me. I'll help you out in getting you some guide or helping out.
Yeah, sir.
Yeah.
I'm also a faculty member in the ACT in aerospace department.
Yes, you can do that. You can register, because
So
it is all only for the members.
We have some research plan to collaboration with the ISRE for the project also, to bring a project for the ACT.
Good. You please join and we'll help you out anything you need.
Yeah, okay. Thank you, sir.
Yeah.
Sir, he is Dr. Yadav, newly joined professor, sir.
Oh, good, sir. Welcome, sir.
He also finished the PhD in IIT, I think, so some other place. So that's why he is asking any funding agency for staffs also available. He is asking.
Sir, for staff only, what is there is they will be given that AICT course is there, sir, which is conducted by on refrigeration and air conditioning. For ISRE and AICT together, they conduct one course for 1 week course. For that, you can nominate where everything will be borne by ISRE. The thing is, like your college management has to sponsor that person for 1 week or some. And days previously, it used to be in some location, but now it is held online only. There are chances that many people can join and get benefited, sir.
Okay, sir. Okay. Sir, suppose we are buying AC for 1 ton for the room size 10 by 15. The cost is around 35,000, sir. If
Yes.
you go for HVAC, the same cost will come, or or is it possible to install for small rooms, sir?
Sir, basically, this unitary ACs, it can be divided into two types: unitary ACs and centralized systems, sir. So it is better that for unitary ACs, you go to 1 or 2 rooms. It is better you go to split or window ACs, or now latest whatever VRF or inverter-based technologies are available. That you can go, sir. If it is for a huge buildings, it is better you go to the centralized plant where your energy conservation and the cost will be less, because for a single room, it is better you install one window or split AC and it is okay. If it is then for big units, ducting and other things, all other equipments are also there. It will be adding your cost. It is better for bigger size plants or office areas. You can go for centralized systems. And if it is going to be for a single room, or we can go to the unitary systems. That is better.
That is better. Okay. Thank you, sir.
Any more questions from the participants?
Okay, if there are no any questions, thank you all students and faculty members for having patience and listening to my presentation. Thank you, sir.
Thank you, sir.
I'm very much sure that all your queries have been cleared very precisely, and we are just left with clarity. Thank you so much, sir. On behalf of Agni ISRE chapter, I would like to thank you for being here to engage and enlighten these young minds amidst your busy schedule. Thank you, sir. We would like to felicitate you with a certificate as a token of appreciation.
Diksha, are you able to present the screen now?
No, sir.
Okay, no issue.
Raj,
Okay.
share the certificate.
I tried to come out, it is not coming out, sir.
Ranganathan, sir. Sir,
Sir.
we will send the appreciation certificate in mail, sir, because he is not able to.
Okay, we will send. Okay,
Yes,
thank
sir.
you, Mohan, sir. Thank you very
Thank
much
you.
for immediately accepting for this webinar. So it will
Thank
be
you,
very
sir.
useful for the student and staff members. So definitely we will submit 2 projects within this 15th, sir. September 15th. Okay.
Diksha, you can go again.
Please. Now, I would like to call upon Dr. Josh Kumar, Head of Department Mechatronics Engineering, to deliver the vote of thanks and bring the session to an end.
Thank you, Subiksha.
What is-
Hope I'm audible here.
Yes, sir. Yes, sir.
So now we have come to the formal end of the program with the vote of thanks. I thank God for enabling us to conduct this workshop in an effective way. Even though we are in different places, the technology has helped us to unite online. With the technology, the webinar topic has also united all the 4 departments of mechanical sciences. I take this opportunity to thank our managing trustee, chairperson, vice chairman, and all those who are part of the management for their approval and support. I thank our beloved principal, Dr. Chandravadana ma'am, for the consistent encouragement and guidance. I thank the head of the mechanical department, Dr. Ranganathan sir, for taking the initiative in conducting this event and for the detailed intro and welcome he gave for Mohan Raj sir. We are thankful to Mr. Mohan Raj sir, scientific officer from Indira Gandhi Center for Atomic Research IGCAR, for spending his valuable time in enlightening our students with all his practical wisdom in the field of HVAC and safety aspects in nuclear ventilation system. I believe this talk would have encouraged our students to learn, work, and do projects in this field. This is a wonderful field where we can have many multidisciplinary projects. Students can also try for these types of government jobs also. I also thank Mohan Raj sir for offering us an opportunity to visit IGCAR. Of course, the Kalpakam beach is also a great place to have fun.
Yeah.
Our sincere thanks to Mr. Marudupandi Raja sir, in absentia, Student Activity Chair, ISRE Kalpakam chapter. My thanks to all the office bearers of ISRE Kalpakam chapter, coordinator, student members, and staff coordinators of our college. I thank Subiksha for being the MC. She is also a student member in ISRE. My special thanks to the IT team of Agni for supporting us through this online event. I must thank all the department heads of mechanical science for the cooperation extended, all the faculties for their support, and all our dear students for their sincere participation. Thank you all. Have a great day.
Thank you. It was
Thank you
nice
so much, sir.
being with you all.
Thank you so much, sir. Thank you, participants. Without you, the event would have remained incomplete. We are expecting you to see again in the upcoming events. Have a great day ahead.
Thank you.
sir. Thank you
Thank
so
you.
much.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
You can leave now.
Yes, sir. The meeting is officially over.
Yeah, yeah.